Biomedical engineering is essentially many different disciplines but with a focus on the human body. It's about using mechanical engineering, electrical engineering, materials engineering, biology, and even computer science and computer engineering to design equipment, devices, and even medicine that's used on and for the human body. So let's start with careers. A common career for biomedical engineers is making artificial limbs. These are for people who have either lost a limb or maybe need to have one amputated. A biomedical engineer would have to design the structure to be similar to a normal human limb. It should be able to deliver a similar amount of force, weigh a similar amount, and so on. They would design the mechanical structure to maintain the best quality of life for the person. For example, if the device is too heavy, it may cause strain on other parts of the person's body, which will lead to problems down the road. This is more of the mechanical engineering aspect of this major. Also, when we want to do something like make a fist, our bodies are sending electric signals to those muscles so it knows what to do. So a biomedical engineer would attach electrodes somewhere near where the limb was removed that would read those electric signals when someone wants to make a fist, for example. Then those signals would be processed and sent to a device that would tell the artificial arm to then make a fist when the person wants to, even if they don't have a hand. This is the electrical engineering and programming aspect of the major. This is also a little preview of how they do brain scans and are even making devices that are controlled using our brains. Then some artificial limbs have a rod that is inserted into the person's body for a better attachment. At the end of the rod that's inside the person's body, they will put coating that encourages the bone to grow onto the rod for a more mechanically secure attachment. Understanding those chemicals that work with the bone and the human body is the biology aspect of this major. Or let's say someone has type 1 diabetes. This means their body cannot produce insulin. So what we can do is create customized beta cells that produce insulin and inject them into the body. But unfortunately, the immune system kills those off because it thinks they are foreign. So what a biomedical engineer can do is take those engineered beta cells and surround them with a hydrogel like polyethylene glycol, and this is just a material that the immune system won't kill. So the insulin can still be supplied from the beta cells inside without being killed off. So you can see that you'll learn how different materials will interact with the body. Whereas another example of this, let's say someone suffered a bad injury where part of their skull had to be removed. What a biomedical engineer could do is create a biomaterial, which is a material that your body won't negatively react to, and this material can be used as a temporary support for the missing portion. Then over time, the bone tissue will start to grow over the material, and the material will then be dissolved and excreted by the body. Because it's a biomaterial, the human body will have no problem with it being dissolved into its system, and the missing part will then be healed over with natural tissue. The engineer would have to find a material that has a lifespan appropriate for how the injury will heal, and make sure it breaks down at the right rate. Then a current advancement in biomedical engineering is designing and printing 3D organs to be used in the human body, like artificial hearts, kidneys, and livers. They recreate a given organ cell by cell using a very precise syringe and stock of various cells needed. This is being used in the military to help soldiers who need a transplant as well. When it comes to the heart, a biomedical engineer could work on a defibrillator. These are the things you see when the doctor says clear, then provides a large shock to the person's chest to try to revive them. That's an external defibrillator, but there's also internal defibrillators. These are located inside the person's body and include sensors that detect when a person's heart needs to jump and automatically provides the shock. These can be slightly painful, but they also save lives. The sensors detect electric signals from the heart, and you know what those signals typically look like? Then if the signal starts changing in a life-threatening way, the device can provide a shock. The nerves, muscles, and heart are very electrically active in our body, so we can sense and manipulate those signals to do useful things. Biomedical engineers can also make pacemakers, which are similar in that they are internal and use small electric pulses to keep the heartbeat rhythm consistent. So if the heart starts to go from consistent beating to abnormal, the device can provide a small shock to get it back to normal. If someone has chronic pain in some part of their body that isn't related to any sort of injury, we can use devices to interrupt or add interference to a pain signal as it travels to the person's brain. This can then replace the pain feeling or greatly reduce it to help the person cope. If you want to go very specialized, you can go into neuroengineering, where you can work on things like providing electric signals to the brain of someone who has severe depression and regulate their mood. This same electrical manipulation can be used on people with Parkinson's disease or epilepsy, which both can be helped through electrical stimulation in the brain. Now, the good news about biomedical engineering is that it's very broad. If you really don't like circuits or the electrical engineering stuff, you can just focus on the mechanical engineering or biology aspect, and vice versa. Now, 3 of the main focuses of the major are biomechanics, bioinstrumentation, and tissue engineering. Biomechanics is the mechanical engineering focus on the body. This is for people who have an interest in the math and physics of the mechanical movement and structure of the human body and even various devices. It includes designing the structure of artificial limbs and analyzing the forces on them, as well as the forces they exert on the body. It can involve looking at the forces throughout a human body as it walks, which is useful in sports, for example. So if a transplant is needed from a sports injury, you can determine how strong and durable that support structure needs to be. Bioinstrumentation is the electrical engineering focus and designing electronics within all the equipment and devices. This is about programming the artificial limb to move based on the electric signals that are being picked up. It's about processing and analyzing signals from the heart, brain, and muscles, then creating circuits and programming devices to manipulate the signals as needed. Then tissue engineering is the biology focus. This would be like determining how to actually 3D print an organ using various cells. Then a mechanical, electrical, and computer engineer would design the 3D printer itself. Tissue engineering also includes how to make a biomaterial that can replace a certain part of someone's body without the body reacting negatively. It can be tweaking cells and generating artificial tissue. An example would be taking someone's skin cells and genetically engineering them to create artificial skin that can help burn victims. And this can even include stem cell research. So even if you don't like some subfield within biomedical engineering, it's okay because there are plenty others to choose from. Now, many students struggle between whether they should major in a specific discipline like mechanical or electrical engineering, or go into biomedical engineering. There's of course no right answer to what is the best choice for you, but here's some guidance. If you know you really want to do mechanical engineering because you like math, physics, and looking at forces, torque, stress, vibrations, or heat transfer on different devices, structures, and supports, or you know that you want to do electrical engineering because you want to work on circuits, signal processing, and programming various devices, but in both cases you want to work with the human body, then you should maybe get your undergraduate degree in mechanical or electrical engineering. The reason is because having one of those on your resume opens up many more doors than having just biomedical engineering. This is not to say biomedical engineers don't have job opportunities, because they definitely do, but it is true that electrical and mechanical engineers have more. Then you could still apply to jobs and internships in the biomedical field, but you'll only focus on the electrical or mechanical aspect of it, and maybe not so much the biology aspect. But you can still get into the biomedical sector. Then an idea is to get a master's degree in biomedical engineering. Some companies will even pay for your master's degree if you work for them. So you can get your bachelor's in mechanical or electrical, then go into the workforce, work for a year or maybe a few, then go back to get your master's. So you'll get a free or cheaper master's degree, have a guaranteed job when you graduate at the company that paid for it, you'll get paid more, and you'll have a very impressive resume that will open up so many engineering opportunities. But if you don't yet know what you're passionate about, but you know you want to work on the human body, then biomedical engineering would be a good idea, because you'll have a focus on the biomedical aspects, but at the same time you'll explore all the various support and elective classes they take, which include mechanical engineering, electrical engineering, materials engineering, and biology classes, and more. So you can get a feel for what you like. And lastly, biomedical engineering as well as biology are common majors for people who want to go into med school, because those majors will fulfill all the prerequisite classes that you need.